Here we have an MS23 board, which I have converted. You can see the EQs on the outside. I even included the 6.8 ohm limiting resistor in case we have regulator dropout. That's because the heatsink that Yaqin have fitted is a bit on the small side, shall we say, and the regulator overheats. But anyway, the purpose of this video is to show what I do to set them up, because as you know, with the LesBox you finish up with little trimmers on each side, little green trimmer there, and they have to be set up. So anyway, let's imagine first of all, well, I better talk about the test gear first. Everything has to be levelled. What I mean by that is, this signal generator is an old ancient HP 209, and that has to go from 20 Hertz to 20 kilohertz without varying its output once you set it. So what we would call a levelled oscillator. And in the same respect, to measure the output from the RAA amplifier, we need an instrument like this that's going to take 20 Hertz up to 20 kilohertz without any variations due to itself. In other words, if you put in, say, 1 volt at 20 Hertz and it shows 1 volt on the scale, you should be able to put in 1 volt at 20 kilohertz and it should still show 1 volt on the scale. And you can connect all your leads up as well to make sure that there's no variations. For example, the output of this oscillator is 0 to 10 volts, which is far too much for an RAA amplifier. It's going to be handling millivolts from the moving magnet pickup. So you need something like this. These are my own attenuator. Well, that's 600 ohms. There's no need to worry about that because you're just using it as a reference once you set it all up. And the important thing is to make sure that that also, says here, having problems getting it reconnected, that is also flat across the audio range we're interested in. Again, 20 Hertz to 20 kilohertz. And it's giving so many millivolts out, we want that to be the same, whatever frequency we go to. I'm feeding that to a splitter, which then feeds both the input channels. It looks a bit hairy, in fact it is. You have to keep your mind on the high volts all the while when you're mucking around with stuff like that. This is a transformer box. It just provides me with 200 volts and 14 volts AC to feed the board with. But obviously later on when the board's fitted in the MS22 or 23, those supplies will be provided by its own transformer. So that's all that one is. Now, a quick check you can do is I'm using a double beam scope, but I mean, if you've only got a single beam, it doesn't matter. You just have to do each channel separately. I'm having great problems with this camera phone. I apologise for that. It's been a real swine this morning. At the moment I'm set at 1 kilohertz. Now, if I go down in frequency to say 100 hertz, well, everything goes up, which is what you expect it to do, because it's going to amplify more down there. When I go to 10 kilohertz, it goes down, which you also expect it to do, because that's what RAA amplifiers do. They boost down at low frequencies and attenuate at the high frequencies. So having done that proves that basically this circuit board is working. All we have to do now is check up its accuracy as we go along. Now I use a simple listing here. Starts at 20 Hertz. and you're looking for 19.3 dB. Having first of all set it up at 1 kilohertz, where you expect it to be 0 dB. So that's all you have to do. Set the 1 kilohertz input, so you get 0 dB on output from the MS23 board. We'll call it that. Well, that's the LesBox board now. You set it for 0 dB. Then you go down in these step frequencies, checking that we get roughly what it says there. And then likewise you go up in frequency. And it's when you get to 10-15 kilohertz you find there's quite an error. So that's when you adjust the trimmer to get it as close as you can to these figures here. Because it alters the gain of that stage, you have to go back and check that your reference 1 kilohertz is still at 0 dB. And if it is, then you can then say, okay, I've done that, and then do the other channel. And hope you'll have a nice set of figures, and that's basically all you need to do. Just a quick note I added on the end. The RMS voltmeter I'm using is a derivative of the earlier HP 3400s. This is a 40 EL, and you'll see that has a special scale. You could either buy these with the volts on the top or the decibels on the top. I'm lucky enough to get one with the decibels on the top because that's what I use mostly at audio. And you can see zeros over there on the right hand side, and that's basically what it is. I normally set it to range 1 and adjust the input to the RIAA from the oscillator until it reads 0, and then from then on you just read straight off the scale as you go up and down in frequency. Makes life quite easy. And then after that, of course, I then print out the graph of the RIAA, which is all done in Excel. Are we allowed to mention that now? Whenever I mention Excel, everybody scorns at me and says, oh, that's not supported anymore. Well, maybe not, but I still find it very useful for a number of things, especially recursive formulas. But anyway, we won't go into that. Cheers.